Good morning friends. In the earlier video, I have discussed about how to convert an Epsilon NFA to an NFA. Okay, that procedure we even call it as a Thomson construction. Okay, now in this video, I will discuss an example of converting Epsilon NFA to an NFA. Let's take that the alphabets are A comma B. For an alphabets A comma B, you have constructed a Epsilon NFA. Why I can say it is an Epsilon NFA? From Q0 on Epsilon you have an move Q1. Whether it is an NFA or not, Q0 on A you have a move, but Q0 on B you don't have a move. So it consists of epsilons and also it is an NFA. So I can call it this one as an Epsilon NFA. So now the given Epsilon NFA I want to convert into an equivalent NFA. How can I do it? We will see it. First, before doing that one, I need to calculate the epsilon closure of all the states. What is the epsilon closure of Q0? Epsilon closure of Q0 is Q0 comma Q1. If you don't know how I got the epsilon closure of Q0, I request you to go and watch my earlier videos. So let me repeat again. Epsilon closure of Q0 is Q0. From Q0 on epsilon where you are going? Q1. So epsilon closure of Q0 consists of Q0 comma Q1. Similarly, epsilon closure of Q1 is Q1 alone. Why? Epsilon closure of Q1 is Q1. From Q1 on epsilon, you are not going anywhere. So only it consists of Q1 only. Now, I need to find the transition table. What is the transition table of Epsilon NFA? It consists of all the states and for all the alphabets. So Q0 on A, you are going to Q0. Q0 on B, you are not going anywhere. Q1 on A, you are not going anywhere. Q1 on B, you are going to Q1 itself. This is the transition table for the given transition diagram. Okay. So now I will calculate the transition, or I will find the transition table for the NFA. This is important. Once you got the transition table, you can easily calculate or construct the NFA transition diagram. Now, as I said earlier, there will be no change in the number of states, and the initial state of Epsilon NFA will act as a initial state in the NFA also. Now we need to find the Q0 on A. How we will do? The procedure is simple. First you need to calculate the epsilon closure of Q0. Let me write it simple. Epsilon closure of Q on X. On that one you need to calculate the delta move. For that one you need to calculate the epsilon closure. Is it visible? Let me write it here. How I will calculate is, first I will calculate the epsilon closure of Q. I will get some states. For that one I need to calculate the transition. For whole one I need to calculate the epsilon closure. You should remember this procedure. Once you know this procedure, it is very easy to construct the NFA. Now, as they are asking Q0 on A. Q0 on A means first I need to calculate the epsilon closure of Q0. Epsilon closure of Q0 is Q0 comma Q1. Now, this is what the first thing we have done. Epsilon closure of Q0 is Q0 comma Q1. Now, Q0 comma Q1 on A, where it is going? Q0 on A is going to Q0. Q1 on A is not going anywhere. So, Q0, Q1 on A is only going to Q0. Please remember again. Q0 on A is going to Q0. Q1 on A is not going anywhere. So, Q0, Q1 on A is going to only Q0. Now, entire one if you do it, we got Q0. Then, epsilon closure of Q0 is what? Q0, Q1. So, Q0 on A is going to Q0 as well as Q1. It is an NFA. So, from any state on any alphabet, you can go to more than one state. So, it is not a single state. When we converted NFA to DFA, we treated it as a single state. Don't get confused. When you are converting an Epsilon NFA to NFA, it will be a two states, because in an NFA, you can go to more than one state. So, similarly, we will calculate the Q naught on B. Q naught on B, first I need to calculate epsilon closure of Q naught. What is the epsilon closure of Q naught? Q naught comma Q1. Q naught comma Q1 on B, where it is going, you need to check. Q naught on B is not going anywhere. Q1 on B is going to Q1. Now you perform union. Union, you will get Q1. So the entire one you got Q1. Now epsilon closure of Q1 is Q1. So meaning is that Q naught on B is going to a state called Q1. Now we will check the Q1 on A. Now Q1 on A, first you have to do epsilon closure of Q1. What is the epsilon closure of Q1? Q1 epsilon closure is Q1. Now Q1 on A is not going to anywhere. Okay. So if it is not going to anywhere, it is 5. So epsilon closure of 5 is 5 only. Please remember again. I need to calculate Q1 on A. First I will calculate epsilon closure of Q1. What is the epsilon closure of Q1? Is Q1. Q1 on A, is it going anywhere? 5. So this total one I will get 5. Epsilon closure of 5 is 5 only. So meaning is that even in the NFA, Q1 on A is not going anywhere. Is it possible or not possible? As it is an NFA, from any state on any alphabet, you may go or you may not go. If you are going, you can allowed to go for more than one state, as in this case, or you may not go anywhere. Okay, so it is possible. It is not a mistake. Now Q1 on B I need to check. Q1 on B. So first what I will do? I will calculate the epsilon closure of Q1. What is the epsilon closure of Q1 is? Q1 alone. Now Q1 on B. Q1 on B transition I need to find. Q1 on B is Q1. So total one I got Q1 here. Now epsilon closure of Q1 is Q1. So Q1 on B is going to Q1. Now I got all the states and all the transitions I got, and I know which is the initial state. Q naught here it is acting as initial state. So even Q naught here also will act as an initial state. Now what are the states will act as a final states? Now if you remember that, what is the final state in the given epsilon NFA? Q1. So which are the states will act as a final states in NFA? So what they said, in epsilon closure of NFA, what are the states when you are calculating epsilon closure of Q0 and Q1, which are the states consists of final state? Q1 is the final state. This one is final state is there, final state is there. So both epsilon closure of Q0 and Q1 is having the final state. So here Q0 and Q1 both will act as a final states. Please check it. Q0 you have, Q1 you have, okay, and these are the two states are only there. Now Q0 on A can go to Q0. Please remember one thing. Q0 on A can go to Q0. Q0 on A can go to Q1. That is what the meaning is. Q0 comma Q1. That's why I did not represent as a one state. Q0 on B is going to Q1. Now Q1 on A is not going anywhere. Q1 on B is going to here. Now which is acting as a final state? These are the two states are acting as a final state, and Q0 is the initial state. So I hope, how many states you got? 2 states you got. That is the step 1. Means points I asked you to remember. There will be no change in the initial state. Here Q0 is acting as initial state. Here also Q0. And there may not be change in there is no change in the number of states. Here 2 states is there. Even here also you have a 2 states. And there may be a change in the final state. Here only Q1 is acting as a final state. In this one you have Q0 and Q1 is both are acting as a final state. So this is the equivalent NFA for the given epsilon NFA. I hope you have understood how I convert an epsilon NFA to NFA. If you have any doubts, I request you to give it in the comment section. And if you people does not understand with one example, don't worry. I will take few more examples for your better understanding. Thank you so much.